find the complete integral of this equation. For that, let's take f to be equal to, I'm taking yp squared to the left hand side, and we get 2z plus xp plus yq minus yp square, right? And now because we are going to use the Charpit's auxiliary equation, for that we need to get what is fx, that is the derivative of f with respect to x. Then also we need to get fy, fz, fp and fq, that's it. So what is fx? It is 2p. And then what is fy? It is 2q minus p square. And fz is equal to, and fp is, it is 2x and minus 2yp. And fq is equal to, it is 2y. That's it. Very carefully find these derivatives. And now let's use the Charpit's auxiliary equations. So these are the Charpit's equations. Let's put all the details. So it is dx divided by fp, that is this value 2x minus 2yp, and I'm going to take 2 outside. So this is x minus yp inside the bracket. And then dy divided by fq, that is 2y, equals to dz divided by p multiplied with fp. This is your fp and I'm going to multiply p, so we get twice of p x minus yp plus q multiplied with fq, so this is 2qy. Let me multiply p inside this and taking q outside. So we have p into x minus yp square, and I'm taking 2 outside. Alright, next we take dp divided by minus of fx plus p multiplied with fz. What is fx? It is 2p, and then p multiplied with fz, so that will be 2p. So 2p plus 2p, that is 4p, equals to dq divided by negative of fy, that is 2q minus p square plus q multiplied with fz. Fz is 2, so q multiplied with 2, that gives 2q. So this will be 4q minus p square. And now I'm going to choose this ratio with equating this with this ratio to get the value of p. So from here I'm going to cancel this. This is minus 2p now, and taking this 2 to the other side equals to dp divided by p with negative sign. And now integrating both the sides, we get, it is 2 log of y equals to minus log of p plus log of a, the constant. So from here we get log of y square. I'm taking this to the left hand side. It is log of p equals to log of a, and then by using the property of log we get py square to be equal to a, the constant. And from here we say p to be equal to a divided by y square, right? Now how to get the value of q from this? We can put the value of p in the given equation, this one, to get the value of q, right? So let's put this value of p over here. This is the given equation. So when putting the value of p, what is p? It is a divided by y square. So writing here a divided by y square plus y into q equals y into p square. What is p? It is a divided by y square. So this becomes a square divided by y the power 4. And cancelling one y from this, we get y cube over here. So writing here y cube, and to get the value of q, alright. Let me take 2yq over here, multiply just 2 inside, and take all the terms to the other side. So this is minus 2z minus 2xa divided by y square, right? And then multiplying all over with 2y, So it is a square divided by 2y the power 4 minus this is z divided by y minus this will be ax divided by y cube, right? So we have got the value of q, and now to get the complete integral we need to use the equation dz equal to p dx plus q dy. Let's put the value of p and q over here now and writing here dy, right? Let me take this term to the other side with dy. So here let me take the LCM. It is y dz plus z dy divided by y is equal to, okay, let me take this y to the other side. So this is equal to y is multiplied with this. So it is a divided by y dx because y is now multiplying with this because of this denominator. So it is ax divided by y square dy plus a square divided by 2y cube dy, right? So how can I write this? dyz, right? And because if I take a outside, I get these two terms in the bracket plus this is a square divided by 2y cube dy. How can I write this? Further, it can be written as a derivative of x divided by y. Please check this. When you open this derivative, you are getting back these two terms. And here dyz plus a square divided by 2, it is constant, and because I am having y cube, 1 divided by y cube, can I write this as the derivative of, because I am having 1 divided by y cube, I can write this to be as derivative of y the power minus 2 with negative sign inside the bracket. Please check this. When you take the derivative of this, what you get? You get negative minus 2 y the power minus 3. This you will get, that is you are getting plus 2 y the power minus 3. That is, it is equal to 2 divided by y cube, which means you need here 2 divided by y cube, you need 2 divided by y cube. So for that we need to multiply the numerator and denominator by 2. That is why I am having here a square divided by 4, a square divided by 4. So that when derivating minus y the power minus 2, I can get back this term. So this is your 4 in the denominator, and now we can easily integrate all these three terms. So from here I get yz to be equal to a into x divided by y plus this is a square divided by 4, and when integrating this we get minus, okay, I write 1 divided by y square plus the constant b. So this is minus a square divided by 4y square. This is minus a square divided by 4y square plus this constant b. B is constant. So now we have got the value of z. You can also divide all over this equation by y, right, to get z alone in the left hand side. You can also leave it as it is. So this is your required complete integral for the given equation. Okay, thank you.